Welcome to Part 9. This is the ninth in a series of our RevSim Virtual Coffee Break series. And this morning you'll hear a little bit in a second from Wolfgang Gintz of the Uber Cloud, who's going to talk to you about a radial fan CFD simulation case study. You'll be able to learn more about this in a few minutes. Along with on the RevSim website, you'll see this and other similar case studies and webinars that we presented on the resources drop-down. For example, if you click on that, you'll see webinars, you'll see newsletters, you'll also find on the website some upcoming events. I invite you to look at our sponsors. We're really growing our sponsor base there. And of course, success stories are what's popular among a lot of visitors to the site. Take a look at who's actually employing democratized simulations, some of the results that they're getting. Alan will talk a little bit more about the RevSim initiative at the conclusion of this video recording. And so right now I'm going to just turn it over to Wolfgang, and he'll jump right into it.
Thank you very much, Bob. Yeah, this is Wolfgang. And today we are talking about a use case from a computational fluid dynamics company in Prague, in the Czech Republic. The company is called CFD Support, and they support manufacturers around the world with numerical simulation in the fluid dynamics space. And one of the main CFD Support businesses is providing full support for virtual prototyping of rotating machines like compressors, turbines, fans, and many other turbo machinery. Interesting is they started quite a few years ago with just focusing on open foam CFD solver, but more and more over time they started focusing on a specific application area, namely turbo machinery, and they turned open foam into an application-oriented environment. Some people call it appification. So it has a much easier user interface with only the most important turbo machinery-based parameters, which can be much easier handled, and which is here really on the spot of democratization of engineering simulations. So all the rotating machines need to be simulated, obviously, to test, confirm, or improve its aerodynamic efficiency, which has major effect on its energy consumption, right? Each machine design is tested many times and is optimized to find the best efficiency point. In practice, these CFD simulations are absolutely demanding because of the complexity and the number of the simulation runs which you have to perform. So in this project we calculated the radial mechanical fan characteristics. We again used the Microsoft Azure cloud here, although we are using any cloud depending on the engineer's request, so be it Google, AWS, Atos, and Advania, for example, in Iceland, OpenCarefree, etc. So the benefit of these clouds obviously is you can run on any different number of cores, right? And so of compute nodes, of compute cores. And the purpose of this project was to test the current fan design and to get the best efficiency possible to save energy cost. And here we see some of the results. You see we ran on-premise on a workstation with 6 cores, and then to compare with, we ran on 2, 4, 8, 16, and 32 cores. And you see, with this simple benchmark, we were able to improve the runtime by a factor of 3. And obviously, you see when you look closer at the timing results on the right-hand side that there is nice scalability. So you could certainly use 64 or 128 cores. Computational fluid dynamics is known usually for being highly scalable. And we have had examples where we used 1028 cores, for example, for CFD simulations. So the beauty with this one also was that we have fully automated the workflow, and so this specific turbo machinery CFD example was again, containerized, meaning everything was included in a portable container and then moved to the Azure cloud and providing immediate access to all kinds of resources underneath without software, hardware setup delays and other interference, especially with the system underneath, and with high performance computing in general. Everything is browser based, user interface is simple, robust and responsive. And if you want to know more about this in much more detail, then just be so kind and download the case study, which you can click on here. And with that, I think I want to hand over to Alan, who describes a little bit more what you could do in your next step to join the revolution in simulation.
Thanks, Wolfgang. Do want to encourage everybody watching to visit the RevSim website. It doesn't matter what role you might have in the community. We have ways that pretty much anybody can participate in the democratization of simulation. It doesn't matter if you're a consumer or a simulation provider, if you're in the media or an analyst, maybe in academia or with an industry organization. We have a nice website page that talks about all the different roles you can play. Those of us that are really engaged are moderators, and we're volunteering our time and efforts into this. There's obviously an executive committee and sponsors. Altogether, we're a big community that's trying to help share best practices and ideas and get the word out about this modeling simulation technology that we think is really going to revolutionize the way things are done. So if you want more information, of course, please do go to the website, register. You just need to enter your email address. On each of these case studies, we have more detail either at theupercloud.com or at osc.edu that you can download. So on behalf of Bob, Wolfgang, and myself, Alan, appreciate you listening, and please tune in to our next virtual coffee break.